Hello, dear grade 6 students again. So, today's lesson we will be talking about 3.2 how to find the greatest common factor and least common multiples. The learning intention of today is number 1. We're going to write the prime factorization, the GCF and LCM, and then the LCM for any two numbers. Success criteria. So number 1, we are going to identify the prime factorization. What does it mean? GCF and LCM. Number 2, we're going to find the GCF and LCM for any two numbers. And number 3, we're going to apply GCF and LCM in solving real life problems. So this lesson is divided into three main ideas, three main parts. We're going to start step by step by dividing it into periods. So we're going to start with period 1. Let's go. So period 1, it's about the prime factorization. Okay, prime factorization, guys, is when you factor a number until you keep on factoring a number until all the factors are prime numbers. Now, prime numbers, you studied it in grade 5, prime numbers and composite numbers. A prime number, it's a number that has only two factors, one and itself. So let's recall here, for example, 13. Think of two factors that when you multiply will give you 13. If you think about it, you have only two factors and they are 1 and 13. So 13 times itself, 1 times any number will give you the same number. So in this case, we call 13 a prime number. Again, why we call 13 a prime number? Because it has only two factors. Okay, it has only two factors, 1 and itself. On the other hand, for example, if I want to find the prime factors for 5, it's going to be the same thing. When I think of two factors, when I multiply will give me 5. I only have 1 and 5. So these are the prime numbers. They have only two factors, 1 and themselves. They don't believe in any other number. Okay, they have so much ego. Yeah. So now about composite numbers, for example, we have the other type of numbers is called composite number. Composite number, it has more than two factors. So for example, 4, what factors if you multiply will give you 4? You have 1 times 4. You have 2 times 2. So as you can see here, the 4, it has three factors, 1, 2, and 4. We don't repeat the factors. We just take 1. No need to repeat. Okay, so this is why we call it a composite number. It has more than two factors. Okay, you can factor it. Now the prime factorization, for example, 40. I'm going to factor it here on the side, guys. Okay. For the prime factorization, if you want to factor any number to its prime numbers, you need, number 1, to draw the factor tree. The factor tree will help you a lot in factoring any number in life. So, think of two numbers that when you multiply, they're going to give you 40. For me, I'm thinking about, I have so many, we have so many factors. I'm going to take 5 times 8. Okay, so step number 1, you have to find two numbers that when you multiply, two factors. Okay, let's use the word factors because factors are the numbers that you multiply together to get the product, to get 40. Okay, now think, is 5, can you factor 5 or is it at its best condition? It's already a prime number and ready to be shipped. What do you think, guys? Obviously 5, if you want to factor it, it has two factors, 1 times 5. So it's useless for me. I cannot take it because I'm going to keep on factoring 5, 1 times 5, and so on. So obviously 5 is a prime number. So if you guys don't want to get confused, what do? You lock it in a circle. So you will know that this number is a prime number. Okay? It's ready to be listed. Now, number 8. Let's look at number 8. Can you factor number 8? As you can see, yeah, we can factor number 8. If you think of two factors, when you multiply will give you 8. We have 2 times 4. 2 times 4 will give you 8. Now, looking at 2. Think about it, guys. Can you factor 2? If you want to think about it, what will give you 2 is only 1 times 2. So we can conclude that 2 is a prime number. So what's going to happen in this case, we're going to lock it in a circle. Now, going to 4, can we factor 4? Yeah. Two factors that when we multiply will give us 4 is 2 times 2. Again, we don't take the 1 times 4 because you guys are going to keep on factoring 4, 1 times 4, it's going to be endless, okay? So please stay away from taking 1 because 1 means the number is prime. It cannot be factored. As you can see here, we reached 2 and 2. Both of them are prime numbers, so we're going to lock them in a circle. So after you are done with factoring, with drawing the factor tree, now it's time to write the prime factorization. Now for 40, we're going to write it from least. When you want to write the prime factorization, please make sure you write it from least to greatest, okay? To keep your, to keep your numbers organized so you don't miss any number while counting. So let's start. My least number is 2. So the prime factorization for 40 is 2 times 2 times 2 times 5. Okay. If I want to double check, what can you do? Simply, you guys can just multiply. So let's multiply 2 times 2. That's 4. 4 times 2, that's 8. 8 times 5, yep, it's equal to 40. So obviously our prime factorization is 100% correct. Okay, now there is another way to write it because in the book it's saying to you, it's asking you to write it using exponents. Okay, you can write it like this way, but sometimes in exams we tell you what's the exponential form. How do you factor 40? And write it using exponents. So the final answer will be, as you can see here, we have 2, we have 3 2s, so we're going to write 2 to the power of 3 times 5 because we have only one 5. Okay, so this is your final answer, 2 to the 3rd power times 5. Okay, now as you can see here, the book's way, maybe you don't want to take 5 times 8. You forgot that 5 times 8 equals 40. You know that 2 times 20 equals 40. So some students will go and take 2 times 20. No matter what 2 factors you take, we're supposed to end up both, you and me, with the same prime factorization. Okay, guys? So look here. He ended up with, as you can see, same as us. 1 2, 2 2s, 3 2s, and 1 5. So that's the prime factorization. We ended up with the same answer. Okay? So it doesn't matter any 2 factors that you guys choose as long as they give you 40 when you multiply them. Remember the steps to find the prime factorization. It's listed here. These steps are really important. Number 1, you need to write the number as a product of 2 numbers. So that means think of 2 numbers that when you multiply will give you 48. You have here 2 times 24. Some of you would like to say, Miss, I don't want this. I want 6 times 8. Or you can think of any other, for example, 12 times 4. If you're good with multiplication and so on. Okay, guys, number 2, we are going to circle and color the prime factors. We're going to circle and color the prime factors. Number 3, we're going to continue until all the factors are prime. Okay? And number 4, you're going to multiply the prime factors. Number 5, you will rewrite them using exponents. So these are the 5 steps. Just keep it simple. Just step number 1, write it as a product of 2 factors. Number 2, circle the prime numbers, and then write it as a list, then rewrite it using exponents. Okay, so guys, I suggest that you solve the questions in your book. They're really important. And in the extra practice worksheet, any question that tells you do prime factorization, please practice that. The more that you guys practice, the more you become fluent in it. It's not that difficult. You just need to be good at the timetable, at your timetable. So let's start here. Write the prime factorization of each number. If the number is prime, you're gonna write prime. Okay, guys? So as you can see here, 33. Let's go on the side here, 33. We're going to factor it now. Think, what two numbers if you multiply will give you 33? We have 3 times 11. So my prime factorization is 3 times 11. This is your final answer, okay? This is how you're gonna do it. Next, let's look at 30. How you guys can factor 30. Think of any two numbers when you multiply will give you 30. I'm gonna pick 5 and 6, okay? As you can see here, 5 is a prime number. I'm gonna lock it in a circle. Oh, I forgot here, 3 is a prime number. 11 is a prime number because they have only two factors, 1 and themselves. So that's why my prime factorization is 3 times 11. Okay, guys? As for 30, I have 5. 5 is a prime number, but 6, I can factor it. I have, it's 2 times 3. I know 2 by 3 will give me 6. Now I reach 2. 2 is a prime. I'm going to lock it in a circle. 3 is a prime. I'm going to lock it in another circle. So my prime factorization for 30 will be, I'm going to write it from least to greatest. It's going to be 2 times 3 times 5. Okay? I hope this question and this question are clear, guys. Okay, I'm gonna delete that. Let me delete that and move on to 27. Question 15, 27, the same idea. Think of two factors. When you multiply, they're gonna give you 27. We have a 3 times 9. As you notice, guys, the 3 is a prime number, so we're gonna lock it in a circle. Then we will head to factoring 9. It's gonna be 3 times 3. Both of them are prime numbers, so lock them in a circle. So 27, the final answer will be 3 times 3 times 3. And as you can see, since 3 is being repeated 3 times, we can write it using exponent. So it's gonna be 3 to the power of 3. So that's the exponent form for 27. Okay? Let's go now to 19. Think about number 19. Okay, so 19, think, guys, can you factor it? Does it have any? Have you ever seen 19 in the times table? I guess not. So it has only two factors, 1 and 19. So obviously in this case, we cannot factor 19. We just write prime. That's it. Easy peasy. Okay, now let's go to move on to number 26. Number 26, now think of two numbers that when you guys multiply will give you 26. You can, since the last digit is 6, which is divisible by 2, so think what's 26 divided by 2. I think it can work. So let's factor it. We know that 2 times 13 will give us 26. As you know, guys, as you noticed, 2 is a prime and 13 is also a prime. We've never seen the 13 in the times table. It has only two factors, 1 and itself. So the prime factorization for 26 is 2 times 13. And that's it. 47. 47, so when you think about it, we've seen 48. We've seen 49 in the timetable, but we've never seen 47. That means 47 has only two factors, 1 and 47. That means it's a prime number. You guys, we cannot factor that. Okay, 47 is a prime number. We cannot factor it. Okay, let's move on to solving word problems about prime factorization. So here in August, the digits of the code number are the prime factors of 150. You guys must know what is the code number of the office door in August. So all you have to do is factor 150. Think, what two numbers if you guys multiply will give you 150? If you guys don't know, remove the 0. Think of 15. What numbers if you multiply will give you 15? So we can think, I want, for example, 15. I can think of 3 times 5. And since I have a 0 in the product, that means one of them should include a 0. So I'm going to add the 0 to 3. So I know now 30 times 5 is equal to 150. Again, the easiest way is put the 0 on the side. Think of two numbers. When you multiply, will give you 15. That's a 3 and 5. Then add 1 0 to one of the factors because you have only 1 0 in the product. Okay, guys? And now let's factor it. Let's go. So we know that 30, what's going to give you 30? You can find easy two factors. You have a 3 and 10. If you notice 3 is a prime, we're going to lock it in a circle. 10, you can factor it. It's 2 times 5. Now we reach 2, it's a prime number. 5 is a prime number, and 5 here is a prime number. So the code for the 150 will be, from least to greatest, it's going to be 2 times the 3 times 5 times 5. So the code to open the safe or something, the code for the door is 2, 3, 5, 5. That's the password. Okay, guys? Yeah, so, this question was like, it's a nice puzzle, so you guys can enjoy while solving it. Now let's look at question 28. We have Gabrielle and John. They each wrote the prime factorization of 64. Okay, we need to analyze their work and see who's correct, who's not correct. Are they both correct? Are they both incorrect? We have to check for any errors, okay? We have to explain their work and check any errors. So let's look at Gabriel's work 64. So he multiplied 8 times 8, so far so good. Then he factored 8, it's 2 times 4, that's correct. The other 8 is 2 times 4 as well. Then he factored the 4, 2 times 2, correct. He factored the 4, 2 times 2, correct. So he's supposed to end up with 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. He ended up with 2 to the power of 6. Okay, his work sounds correct. It sounds 100% correct. Let's look at John. John, he decided to write the factors, the prime factorization, as a list. He listed it instead of doing the factor tree. So is his work correct? Let's check. So he took the numbers 2 times 32 is equal to 64. He's correct. Then he factored 32 as 2 times 16. Yep, that's correct. Then he factored 16 as 2 times 8. Yeah, then he factored the 8 as 2 times 4. Then he factored the 4 as 2 times 2. So he ended up with how many 2's? 1, 2, 3, 4, 5, 6. So that's 2 to the power of 6. So they both ended up with 6 2's, or 2 to the power of 6. For me, I can see no error. Both of their work is 100% correct. Gabrielle, she just used the factor tree, while John, he listed the factors. Okay, they both ended up with the same answer. Both of them, they have correct answers. Okay, sometimes, guys, you could be getting the same question in the exam, but they could be telling you have to double check, like what I did now. This is how you're gonna solve it. You're gonna double check the prime factorization. Sometimes only one digit is wrong. Like here, he ended up in 2 to the power of 6, and here he ended up 2 to the power of 5. So you can guess, when you solve it yourself, you can tell what was the mistake. Or maybe they gave you the work, but they wrote the last step, this one, incorrectly. So you guys, when you get a question like that, you need to analyze it really well and check, look for any errors if there are. Try to solve each question by yourself in both ways. This is the way if you guys want to analyze errors. Okay? Now, last question for this part of the lesson. The same idea as the top one, as the 150. You need to, here they gave you the prime factorization, guys. It's ready. So all you have to do is just pick the right answer. As you can see, when you write it from least to greatest, it's 2 times the 3 times the 3 times 5. So yep, your answer will be, it's very obvious, it's D. Okay, so sometimes the questions are not that difficult. They're just straight to the point. So that's part 1 of of finding the prime factorization of this lesson, finding the GCF and LCM. Okay, let's move on now to part two. Part two, it's about finding the greatest common factor, which is finding the GCF. Let's go.